Okay, in this example here, for this function, which is defined as f of x equals x square root of 8 minus x squared, we're asked to first of all find intervals on which f of x is increasing and decreasing. We're to identify any local extreme values for f of x, okay, and we are wanting to find if any extreme values occur, if any of these are actually absolute extreme values. Okay, now our standard technique for this is, first of all, we have to find what the critical points are, because extreme values only occur when the first derivative is 0 or the first derivative is undefined. Alright, so let's start part A. Alright, now in part A we want to find intervals where it's increasing, so we're going to need the derivative. So first of all I'm going to write the function in exponent form. Alright, so this now will be our function, x by 8 minus x squared to the power of a half. Our derivative then is going to require the product rule by the chain rule. Okay, now the product rule, remember, is going to be the derivative of the first function times the second function plus the first function by the derivative of the second function. So be very sure that you know how to do the product rule. Okay, in this case here the derivative of x is 1 and we multiply it by the second function. Okay, plus the first function, which is x, and now we have to do the derivative of the second function. Alright, it's going to be a half by 8 minus x squared, this is the chain rule. Subtract 1 off will give me a negative a half, and now we have to multiply by the inside function, which is negative 2x, and that will be our product rule with the chain rule. So notice it's the derivative of the first function x by the second function plus the first function by the derivative of the second function. Here requires the chain rule, and so you bring the half down, 8 minus x squared, take 1 off the exponent, gives us negative a half, multiplied by the derivative of negative x squared, because the derivative of 8 is 0, so it's negative 2x. Right, we now go ahead and simplify this, because we've got to get it into a form to find when it's going to be equal to 0. Alright, so to do that, of course, we have 8 minus x squared to the half. Now, with this one here, we'll see that the half goes with the 2 here, and we have a negative x squared. And of course, we have this now over 8 minus x squared to the half, to make it a positive exponent. Alright, to deal with this we need to find a common denominator, which will be 8 minus x squared to the half, and to do that we're going to have to multiply this 8 minus x squared to the half by 8 minus x squared to the half, which gets rid of the half, and we're subtracting off x squared. So at the end of the day our derivative here is going to be 8 minus 2x squared over the square root of 8 minus x squared, and that will be our first derivative. Alright, so that's the way we find this derivative. Now remember that the critical points, and let's do the critical points now. So let's move this up, and we're going to have this. Alright, so here's our function. Alright, so this is our derivative function, and of course we're going to now look at the critical points. Alright, now these occur when f dash of x, first derivative, equals 0, or f dash of x is undefined. Right, so if we look at our function, Okay, we can see first of all where this is going to be 0. It's going to be when the numerator is 0, so this is going to be when 8 minus 2x squared equals 0, and this will be when 2x squared equals 8, or x squared equals 4, which means x is equal to plus or minus 2. Okay. Right, next, undefined, of course, is going to be, if you look at the function, the undefined is going to be when 8 minus x squared, right, is going to be equal to 0. So this is going to be when 8 minus x squared equals 0, or x squared equals 8, or x equals plus or minus the square root of 8, which of course is plus or minus 2 square root 2. Okay, so we now have the critical values. Like so. Alright, now what I do is this: I draw a number line like so, because I want to find where it's increasing, and the function will be increasing when the derivative is positive and decreasing when the derivative is negative. Alright, so we do a number line. Let's put 0 here, and of course we're going to have 1, let's say 2 here, and 1 negative 2 here. Now also we're going to look at this plus or minus 2 square root 2. Now the square root of 2 is approximately 1.414, times 2 is about 2.8. So we're going to put that here, and I can't have that value. Okay. In fact, that's the end of the domain for the function. You'll remember that the function alright, if you look at the function here, was x square root of 8 minus